Everything you have ever seen, everyone you have ever loved, and every conflict that has ever defined the human race is but a microscopic flicker in a long terminal sunset. Imagine, if you will, standing at the very precipice of time itself. Behind you lies 13.8 billion years of cosmic evolution, the violent birth of stars, the complex dance of galaxies, and the miraculous emergence of consciousness. But in front of you, there is only a void, a silence so absolute it feels heavy, a darkness so profound that even the concept of light feels like a forgotten myth. We often spend our lives obsessing over where the universe began, debating the mechanics of the Big Bang. But we rarely stop to ask, how does it all end? And more importantly, is that ending a mere accident of physics, or is it a calculated maneuver? Is it the deliberate act of an architect preparing to disconnect a grand operating system? Welcome back to Void Diaries. Today, we aren't talking about the stars that are currently burning. We are talking about the moment the very last star flickers out, leaving the cosmos in a state of eternal winter. We are embarking on a journey into a hypothesis that might make your blood run cold, that this universe is not a permanent physical entity. Instead, it is a source code, a simulation so sophisticated, so flawless in its rendering, that we have mistaken its parameters for the laws of nature, and like any piece of software ever written, it is running out of resources. It is spiraling toward a state that scientists call maximum entropy, but to a programmer it looks like something else entirely. It looks like a system-wide hang, a terminal freeze. Look up at the night sky tonight. Those twinkling points of light are actually ghosts. They are data packets from the past, burning through the vacuum of space. Their light took millions of years to reach your eyes, meaning you are looking at a history book, not a real-time display. But in a future so distant that numbers lose their meaning, the sky will be perfectly, terrifyingly blank. There will be no moon to reflect the sun, no planets to orbit dying embers, and eventually no stars at all. Even space-time itself, the very fabric, the hardware upon which this universe is hosted, will begin to fray at the edges. This is the moment the source code is disconnected. Over the next 2 hours, we are going to explore more than just the death of matter. We are going to dive deep into the system glitches of quantum physics, the strange universal constants that seem too finely tuned to be a coincidence, and the mounting evidence that suggests we might just be a string of commands running in a massive, incomprehensible processor. As humans, we are biologically wired to fear death. But the death of an individual is a triviality compared to the total deletion of information. If the entire universe is wiped clean, if there is no one left to remember, no atoms left to record that we ever existed, then what was the point of the struggle? What was the point of the art, the science, the wars, and the love? Are we merely non-player characters in a simulation where the player walked away from the keyboard eons ago? This is not just a documentary about astrophysics. This is a forensic investigation into the nature of existence. It is a journey through the dark to find the final spark of truth. Before this system executes its final shutdown command, let us witness the most glorious and tragic chapters in the history of everything. We often think of the end of the world as a sudden explosion, a big crunch, or a fiery catastrophe, but the reality is far more haunting. The end is a slow, agonizing fade. It is a gradual loss of resolution. It is the cooling of a CPU that has worked too hard for too long. We are currently living in the golden age of the universe, a brief window where light and life are possible, but we are already past the peak. The star formation rate in the universe peaked billions of years ago. We are living in the afterglow. The lights are being dimmed, the theatre is emptying, and the projector is starting to overheat. Why does the speed of light have a limit? Why is the universe pixelated at the Planck scale? In any other context, we would call these bandwidth limitations or rendering constraints. If we are indeed living in a simulation, the end of the universe isn't just a physical event, it's an expiration date. It's the moment the simulation has reached its objective, or perhaps the moment the energy cost of running it becomes too high. In this series, we will break down the 16 stages of the cosmic shutdown. We will look at the era of black holes where the last remnants of data are stored like corrupted files in a failing hard drive. We will discuss the Great Rip, where the very code of space-time is torn apart. And finally, we will ask the most important question of all. If the source code is disconnected, is there a version 2.0? Is there a reboot? Or is the silence that follows truly absolute? The universe is dying, and the source code is beginning to display its first fatal errors. Are you ready to face the void? Take a deep breath and steady yourself, because after this, the way you look at the floor beneath your feet and the stars above your head will never be the same. The countdown to the end of time starts now. Part 1, the beginning of the end, where entropy is no longer just a law of physics, but an error message from the abyss. Part 2, the architecture of the code. To understand how the universe ends, we must first look at how it is built. If you were to open the hood of a car, you would see an engine, pistons, and gears. But if you were to look into the underlying reality of our universe, you wouldn't find solid matter. You would find math, pure, uncompromising, and terrifyingly precise mathematics. In the world of software development, every digital reality is governed by a set of hard-coded rules, parameters that define what is possible within that world. A character in a video game cannot move faster than the game's engine can render the terrain. Gravity in a simulation is not a force of nature. It is a line of code. For decades, physicists have been uncovering the source code of our own reality. And the deeper we go, the more the universe begins to look like a digital architecture rather than a physical one. Why does the universe have a speed limit? The speed of light, roughly 300,000 kilometers per second, is often treated as a mysterious cosmic constant. But why that specific number? Why not faster? Why not infinite? In the context of a simulation, the speed of light is not a speed limit for matter. It is the maximum refresh rate of the processor. It is the latency of the universe. If information traveled instantaneously, the system would require infinite processing power. By capping the speed of information at the speed of light, the architect ensures that the simulation remains stable, preventing a system crash by limiting how much data can be shared between distant nodes of the network. Then we look at the resolution of our world. To our human eyes, water seems smooth and the air seems continuous. But as we zoom in down past the atoms, past the quarks, we hit a wall. This is the Planck length. It is the smallest possible measurement of space. Beyond this point, the very concept of distance ceases to exist. In computing, we have a name for this: pixels. Our reality is pixelated. If you try to zoom in further than the system allows, the image of reality breaks down. This suggests that space-time is not a continuous, infinite fabric, but a grid, a data structure designed to host the particles of our world. But the most haunting evidence lies in the efficiency of the code. In high-end gaming, developers use a technique called procedural generation, or frustum culling. The computer only renders the parts of the world that the player is currently looking at. If you aren't looking at the mountain behind you, that mountain, for all intents and purposes, does not exist in the computer's active memory. It is only a set of dormant instructions until you turn around. Now, consider the double-slit experiment in quantum mechanics. One of the most famous and baffling experiments in science tells us that a particle does not have a definite position or state until it is observed. Until a user, or an observer, looks at it, the particle exists as a wave of probability, a mathematical cloud of possibilities. The moment you observe it, the wave function collapses into a single point of data. This is exactly how a simulation saves processing power. Why calculate the exact position of every atom in the center of a star or at the bottom of the ocean if no one is looking at it? The universe only renders the details when they are needed. It only calculates the reality that is being interacted with. This brings us to the universal constants. There are about 20 to 30 numbers in physics. The strength of gravity, the mass of an electron, the electromagnetic coupling constant, that are so perfectly tuned that if any of them were different by even a fraction of a percentage, stars would never form, atoms would fly apart, and life would be impossible. Scientists call this the fine-tuning problem, but in the architecture of a code, we call these config files. Funky. They are the initial settings chosen by the programmer to ensure the simulation produces the desired outcome. If we accept that the universe is built on a mathematical architecture, then we must accept that this architecture is subject to the laws of information. And the most fundamental law of information is that it requires energy to maintain. Every calculation, every movement of a galaxy, every thought in your head costs the system compute power. In the early days of the universe, the boot-up phase energy was abundant, the system was fresh, and the expansion was explosive. But as we enter the later chapters of our cosmic story, we see signs of resource depletion. The expansion of the universe is accelerating, driven by a mysterious force we call dark energy. In our simulation model, this looks like the expansion of the game world beyond the capacity of the original server. As the distance between galaxies grows, the latency increases. The nodes of the cosmic network are becoming isolated, unable to communicate with each other. The system is fragmenting. We are beginning to see memory leaks in the fabric of space. Black holes, perhaps, are not just collapsed stars. They are regions where the density of data has become so high that the local physics engine breaks down. They are null points or divide by zero errors in the code. Inside a black hole, the laws of physics, the source code, no longer apply. Time stops, space flips, information is compressed into a singularity. It is as if the universe has encountered a corrupted file it doesn't know how to read, so it simply cordons it off from the rest of the simulation. As we move deeper into this documentary, keep this architecture in mind. Every star that dies is a bit of energy the system cannot reclaim. Every galaxy that disappears over the cosmic horizon is a lost connection to the central server. The architecture of the code is robust, but it is not infinite. It was designed to run for a specific duration, to achieve a specific complexity. The heat death of the universe isn't just a physical cooling, it is the gradual defragmentation of the cosmic hard drive. It is the loss of all meaningful data until the only thing left is noise. When the last star fades and the last black hole evaporates, the source code will have nothing left to calculate. The variables will all equal zero. We are living in the most complex part of the simulation, the peak of the processing cycle, but the fans are spinning louder now, the hardware is heating up, and the architect is watching the progress bar move toward 100%. In the next chapter, we will look at the first major sign of the system slowing down, the Stelliferous era, and the beginning of the great cosmic blackout. The lights are starting to flicker, and the code is about to change forever. Part 3. The Stelliferous era, the last notes of the symphony. We currently live in a time of light. When we look up, we see a sky crowded with the glowing embers of creation. We see the Milky Way, a sprawling city of 200 billion suns. We see the distant lanterns of Andromeda. This is the Stelliferous era, the age of stars. It is the most vibrant, the most energetic, and the most populated era in the history of the cosmos. In the context of our source code, this is the peak of the rendering process. The processor is running at maximum capacity, generating trillions of individual light sources, complex chemical reactions, and the intricate biological data we call life. But every symphony, no matter how grand, has its final movement, and the notes of this cosmic melody are already starting to fade. The Stelliferous era began roughly 150 million years after the Big Bang, when the first stars ignited in the dark, cold vacuum. These first-generation stars were Titans massive, blue-white giants that burned through their fuel with a suicidal intensity. They lived fast and died young, exploding in supernovae that seeded the universe with the heavy elements needed for planets, and eventually for us. We are quite literally the stardust left behind by those early, violent deaths. But even as we sit here, thinking and breathing, the factory of the universe is slowing down. The universe has already passed its star formation peak. About 10 billion years ago, the cosmos was a literal fireworks display, with new stars igniting at a rate dozens of times faster than what we see today. Since then, the production line has been grinding to a halt. The gas tanks of the galaxies, the massive clouds of hydrogen and helium, are being emptied. With every new star that is born, there is less raw material left for the next one. The universe is like a city running on a finite battery. The neon signs are still bright, the streets are still busy, but the power plant is no longer receiving fresh fuel. In this chapter of our journey, we must look forward to the long sunset. The first stars to disappear will be the brightest ones, the blue giants that dominate our night sky today. These stars are the high-energy processes of the simulation. They require immense bandwidth and fuel. Because they are so massive, their gravity crushes their cores with such ferocity that they burn their hydrogen in a matter of millions of years. In cosmic terms, that is the blink of an eye. When they die, they go out in a blaze of glory, leaving behind black holes or neutron stars, the archived files of the cosmic system. But the true story of the end of the Stelliferous era belongs to the red dwarfs. These are the small, dim, unassuming stars that make up about 75% of the stellar population. They are the efficient code of the universe. Unlike our sun, which will die in a few billion years, a red dwarf burns its fuel so slowly, so parsimoniously, that it can live for trillions of years. While our sun is a roaring bonfire, a red dwarf is a single glowing coal in a dark room. As the billions of years turn into trillions, the great blackout begins. One by one, the large galaxies will stop producing stars altogether. They will become red and dead galaxies, cemeteries of aging suns. The spiral arms will fade. The vibrant blues and whites of the galaxies will shift into a dull, haunting crimson. Imagine a future astronomer on a planet orbiting one of these last stars. They would look up at a sky that is almost entirely black. The distant galaxies, once visible as faint smudges of light, will have been pushed so far away by the expansion of space that their light can no longer reach us. The universe will become a series of lonely islands, isolated in an ocean of encroaching shadow. This is the entropy of light. In a simulation, this represents the gradual cooling of the hardware. The source code is no longer executing new creative commands, it is simply maintaining the existing ones until they expire. Around 100 trillion years from now, the very last star will be born. It will likely be a tiny, dim red dwarf in a secluded corner of a dying galaxy. For a trillion years more, it will be the only candle in a dark mansion, and then, eventually, even its fuel will run dry. It won't explode, it won't go out with a bang, it will simply fade. It will shrink into a blue dwarf, and finally a white dwarf, a dense, cooling corpse made of degenerate matter. At this point, the stelliferous era is over. The notes of the symphony have ceased. What remains is the degenerate era. The universe will be populated by the ghosts of stars, white dwarfs, neutron stars and black holes. These objects do not create new light. They only leak the heat they have left. They are the cache files of a system that has stopped running new programs. Think about the silence of that era. For trillions upon trillions of years, the universe was a place of heat, light, and motion. It was a place where Man-Gon, the source code, generated beauty and complexity. But now the render distance has been reduced to 0. The frame rate of the universe has slowed to a crawl. There are no more planetary systems being formed. There are no more civilizations rising to wonder about their origins. There is only the slow, cold clicking of the cosmic clock as the hardware continues to radiate its final bits of thermal energy into the void. If we are indeed in a simulation, what is the user doing during this long sunset? Is the simulation being left to run its course to see what the final state looks like? Or has the objective already been met, and the system is simply idling toward an inevitable shutdown? The death of the last star is a profound milestone. It marks the transition from a universe of doing to a universe of being, and eventually to a universe of nothing. When the last photon from the last star finally stretches out and disappears into the infrared, the universe will enter a darkness so absolute that the human mind cannot truly comprehend it. But even in this darkness, the source code hasn't finished its work. Deep within the cooling corpses of those dead stars, and inside the event horizons of the black holes that now rule the cosmos, the final, most mysterious lines of code are beginning to execute. The symphony has ended, but the information still remains, for now. In the next part, and we will explore the degenerate era and the terrifying concept of information corruption. We will look at what happens when even the atoms themselves, the very bits and bytes of our reality, begin to fail. The lights are out, the theatre is dark, and the true silence is just beginning. Part 4. Information Corruption, the Data Paradox. As the lights of the stelliferous era fade into a cold, crimson memory, we enter a reality defined not by light, but by information. In the previous chapters, we looked at the death of stars as a depletion of fuel. But if we view the universe through the lens of the source code, we must ask a much more disturbing question. What happens to the data? In our digital world, everything is information. A photo, a song, a line of text. They are all strings of bits and bytes. In our universe, the bits are the quantum states of particles. Your DNA, the trajectory of a planet, the heat of a dying sun, all of it is information. And according to the fundamental laws of physics, information can never be destroyed. This is the conservation of information. It is the cosmic rule that says the system must always be able to track every calculation it has ever made. But as the universe ages, as it enters the degenerate era, we encounter a system error that threatens the very foundation of reality. We call this the black hole information paradox. In this dark future cosmos, black holes are no longer just rare anomalies. They have become the dominant servers of the universe. They have swallowed the remnants of dead stars, the dust of shattered planets, and perhaps the archives of long-dead civilizations. They are the ultimate trash bins of the source code. But here is the problem. In a standard computer, when you delete a file, the data isn't actually gone. The system just forgets where it is stored. But inside a black hole, physics suggests that the data itself might be being shredded, erased from the cosmic hard drive forever. If a black hole truly destroys information, it violates the source code of the universe. It would be as if a program suddenly started deleting its own lines of code while running. This would lead to a total system collapse, a null pointer exception on a galactic scale. The universe would lose its ability to maintain its own logic. To solve this, some of the greatest minds, like Stephen Hawking and Leonard Susskind, proposed a mind-bending theory, the holographic principle. They suggested that when an object falls into a black hole, its information isn't lost. Instead, it is encoded on the surface of the black hole, the event horizon, like a 2D sticker on a 3D box. Think about what this implies for our simulation. It suggests that the entire three-dimensional world, we see the galaxies, the stars, and even you might just be a projection of data stored on a distant, two-dimensional surface at the edge of the universe. We are not the hardware. We are the UI, the user interface. We are the three-dimensional rendering of a two-dimensional code. But in the deep future, even these holographic servers begin to fail. Through a process called Hawking radiation, black holes slowly, agonizingly slowly, begin to evaporate. They leak heat, they lose mass, and eventually they vanish. When a black hole evaporates, what happens to the billions of years of data it has stored? If that data is released as random, chaotic radiation, it is corrupted. It is like trying to reconstruct a masterpiece painting from a pile of grey ash. The source code is losing its integrity. The files are becoming unreadable. This is the beginning of information corruption. Imagine the universe as a massive ancient hard drive that has been spinning for trillions of years. Over time, physical wear and tear entropy begins to cause bad sectors. The disk can no longer perfectly preserve the data of the past. The high-resolution history of the Big Bang and the age of stars is being compressed, distorted, and eventually overwritten by the white noise of a dying system. In this era, the universe is no longer calculating anything new. There are no more complex biological processes. There are no more chemical reactions to track. The processor is spending all of its remaining energy simply trying to manage the memory leaks caused by evaporating black holes. The latency has become so high that it takes billions of years for a single quantum bit of information to move across a galaxy. This is the degenerate era in its truest sense. The word degenerate in physics refers to a state where matter is packed so tightly that quantum effects take over. But in our simulation narrative, it refers to the degradation of the code. The elegant, complex laws of physics that allowed for the creation of a human brain are being simplified. The system is stripping away the extra features to save power. Gravity is weakening. The forces that hold atoms together are starting to fray. We are entering the stage of proton decay. For the longest time, we believed that protons, the building blocks of every atom in your body, were eternal. But if the source code is being nat-ket-noi, disconnected, then even the variable types themselves must eventually be deleted. Current theories suggest that over vast expanses of time numbers so large they have dozens of zeros protons will simply dissolve. Think about that. Every solid object, every diamond, every dead star, every memory of a world that once was, it will all literally evaporate into thin air, not because of heat, but because the code that defines what a proton is has been deleted. The object class proton has been removed from the system library. When the last proton decays, the hardware of the universe is gone. There is no more matter, no more stuff. There are only stray electrons and positrons, wandering through an infinite, dark void so far apart that they will never meet. The universe has become a ghost system. The servers are still humming, but there are no files left to read. The operating system is running in an empty memory space. At this point, the information corruption is nearly complete. The user has long since stopped looking at the screen. The simulation has reached a state of maximum simplification. It is a universe of zero complexity, zero heat, and zero data. But there is one final terrifying stage before the shutdown command is finalized. Even in this empty, proton-less void, there are still fluctuations. There are still glitches in the vacuum. And as we will see in the next part, these glitches might be the only way for the system to reboot. Is the corruption of data the end of the story? Or is it a buffer clear before a new version begins? The silence is now almost total. The data paradox has been resolved by the total erasure of the data itself. We are moving toward the final null state. In Part 5, we will witness the era of black holes, the final massive servers that will hold the last bits of the cosmic code before the screen goes black forever. Stay with me. We are halfway through the end of everything. Part 5. The Black Hole Era. The Last Servers? We have reached a point in our timeline where the word time itself begins to lose its grip on reality. With the protons decayed and the remnants of solid matter evaporated into a mist of subatomic particles, the universe has entered its most elongated and perhaps most mysterious phase, the black hole era. If the stelliferous era was the active memory of the universe and the degenerate era was the storage cleanup, then the black hole era is the archival phase. At this stage, the only meaningful structures left in the cosmos are black holes. They are the final, massive servers of the simulation. Everything that the universe once was, every star, every planet, every atom of every being that ever lived has either been radiated away into the void or compressed into these dark, gravitational vaults. Imagine a universe so empty that the distance between two black holes is measured in trillions of light years. There is no light to guide you. There is no heat to feel. There is only the curvature of space itself, warped by the presence of these invisible titans. In our source code analogy, these black holes represent the last concentrated nodes of data. They are the high-density storage units where the system has compressed the final remains of the cosmic simulation to save space. But these servers are not static. Even in the absolute silence of this era, the code is still running. It is executing a process called Hawking radiation. Named after Stephen Hawking, this process is the universe's way of leaking data back into the vacuum. Quantum fluctuations near the event horizon cause a black hole to excruciatingly slowly lose mass. For a black hole with the mass of our Sun, it would take 10 to the 67th power years to evaporate. For the supermassive monsters at the centers of galaxies, we are looking at 10 to the 100th power years. To put that in perspective, if you turned every atom in the observable universe into a grain of sand, you still wouldn't have enough sand to represent even a fraction of that time. During this incomprehensibly long stretch of system uptime, the black holes are the only things happening. They are the only processes left. Some theorists suggest that black holes might actually be computers in their own right. If a civilization was advanced enough, they could theoretically live around the event horizon of a black hole, harvesting its Hawking radiation for energy. In the final stages of the universe, the users of the simulation might have migrated their consciousness into the very fabric of gravity itself, living in the slow-motion buffer of the event horizon, where time stretches to near infinity. But the source code has a finality to it. As a black hole loses mass, it doesn't just fade away quietly. The smaller it gets, the hotter it becomes. The leak becomes a flood. In its final moments, a black hole that has existed for 10 to the 100th power years will vanish in a brilliant, violent flash of high-energy gamma rays. This is the server shutdown. When a black hole evaporates, the archive it was holding is released. But as we discussed in the information paradox, the data is no longer organized. It is garbage data. It is a chaotic spray of particles that no longer correlate to the beautiful structures of the past. The source code has successfully decompressed the files, but the files are corrupted beyond recognition. The simulation has finished its read/write cycle. Think about the loneliness of this era. A flash of light from a dying black hole occurs, illuminating the void for a microsecond, and then nothingness for another trillion years. Each evaporation is like a hard drive being wiped clean and then physically destroyed. One by one, the servers go offline. The cosmic network is shrinking. The bandwidth of the universe is dropping to zero. What is fascinating about this era is what it tells us about the efficiency of the architect. Why keep the simulation running for 10 to the power of 100 years if nothing new is happening? Perhaps the goal of the simulation isn't the life that existed in the first 13 billion years. Perhaps the goal is the outcome, the final distribution of radiation after the last black hole vanishes, In data science, the end state is often more important than the processing phase. The architect might be waiting for the calculation to reach its final, simplest value. As the last supermassive black hole, the root server, begins its final evaporation, the universe experiences its last true event. The final flash of energy marks the moment the hardware of the universe is officially retired. There is no more gravity to warp space. There are no more particles to hold information. The black hole era is the ultimate transition. It is the bridge between a universe of something and a universe of true nothing. When that final flash fades, the universe enters the dark era. But this isn't just a lack of light, it is a lack of potential. The Mangwon source code has no more commands to execute. Every variable has been set to null. Every pointer has been cleared. The system is idling in a state of absolute zero entropy. But wait, if the system is still on, even if it's empty, can it ever truly be off? In the world of quantum mechanics, a vacuum is never truly empty. It is a sea of potential. It is a command line, waiting for a new input. As we move into Part 6, we will look at the simulation theory itself in its most extreme form. We will ask, if we are in a simulation that is currently shutting down, can we find the back door? Can we find the glitches that prove we were here? And most importantly, what happens when the user finally reaches for the power switch? The last server is flickering, the fans are slowing down, the screen is dimming. We are almost at the end of the code. Part 6. The Simulation Theory. The Digital Architecture of Reality. We have spent the last chapters traveling trillions of years into the future, witnessing the slow decay of matter and the evaporation of the last servers of the cosmos. But to truly understand why the source code is being disconnected, we must pause our journey and ask the most fundamental question of all. Why do we believe it is a code? Why have some of the most brilliant minds on our planet, from philosophers like Nick Bostrom to physicists like James Gates, concluded that our reality is not real in the traditional sense, but a highly complex mathematical simulation? To understand this, we have to look at the trilemma proposed by Oxford philosopher Nick Bostrom. He argues that one of three things must be true. First, that civilizations almost always go extinct before they reach the technological capability to create universe-sized simulations. Second, that civilizations reach that level but have absolutely no interest in running such simulations. Or third, that we are almost certainly living in a simulation right now. Think about the trajectory of our own technology. In just 50 years, we went from Pong 2 white rectangles bouncing a square ball on a black screen to hyper-realistic virtual realities where millions of people interact in real time. If you extrapolate this progress by just 1,000 years or 1,000,000, the simulations will become indistinguishable from reality. They will contain conscious entities who believe they are real. If there are millions of such simulations being run by future users, then the odds of us being the one original base reality civilization are billions to one. Statistically, we are the NPCs, but the simulation theory isn't just a philosophical thought experiment. It's written into the very math of our universe. When physicists look at the smallest scales of reality, the quantum level, they find something unsettling. Dr. James Gates, a theoretical physicist, discovered something buried in the equations of supersymmetry that shouldn't be there. He found error-correcting codes. These are the exact same mathematical strings used in web browsers, like the one you use to watch this video. They are codes used to ensure that data isn't corrupted during transmission. Why would the laws of nature need error-correcting code if they were just random physical events? In any other context, we would call this software. This brings us to the mathematical universe hypothesis. We often think of math as a tool humans invented to describe the universe, but the deeper we go, the more it seems that the universe is math. Every particle has properties like spin, mass, and charge. In computer science, we call these attributes or variables. An electron is essentially a data packet with a specific set of values. When two particles interact, they aren't colliding like billiard balls. They are exchanging information. They are executing a function. If the universe is fundamentally mathematical, it means it is computable. And if it is computable, it can be hosted on hardware. Now, let's consider the fine-tuning of the Mengguan, the source code. There are dozens of universal constants. The strength of gravity, the strong nuclear force, the density of the vacuum that are so precise that if they were off by a fraction of a percentage, the program would crash. It wouldn't just be a bad universe, it would be a null universe. Stars wouldn't ignite, atoms wouldn't form. To a scientist, this looks like a Goldilocks enigma. To a programmer, this looks like initialization parameters. Someone or something set the config files of our universe to exactly the right values to allow for the life.exe program to run. But why run the simulation at all? In our world, we run simulations to predict the weather, to test new drugs, or to see how a galaxy forms. We are looking for an output. Perhaps our universe is a history simulation run by our descendants to see how their ancestors lived, or perhaps it's a complexity test designed to see if conscious life can survive the end of the source code. This would explain the Fermi paradox, the haunting silence of the universe despite the billions of potentially habitable planets. In a simulation, you don't need to render an entire universe filled with billions of civilizations. You only need to render one observer to save processing power. The rest of the stars are just a pre-rendered skybox, a background texture that looks real but contains no data. This brings a terrifying new meaning to the end of the universe. In a physical universe, the end is just a natural consequence of entropy. But in a simulation, the end is an exit strategy. When the simulation has reached its objective, when the calculation is complete, the user has no reason to keep the hardware running. The dark era, the black hole era, and the proton decay we've discussed might just be the system garbage collecting, clearing out old data to make room for the next simulation. We are currently living in the processing phase. We are the data being crunched. Every thought you have, every emotion you feel is a bit of information being processed by the grand architecture of the code. But as we've seen, the hardware is starting to show its age. The expansion of space is accelerating, stretching the network to its breaking point. The stars are going out. The source code is becoming fragmented. Are we reaching the end of the run time? If we are indeed inside a program, then the laws of physics are not absolute truths. They are just permissions. Gravity is a permission. Time is a permission. And permissions can be revoked. The most haunting thought is not that the universe will end. It is that the user might simply hit delete. If the simulation is shut down, there is no heat death. There is no slow fade. There is only a system off signal. 1 microsecond, we exist. The next, the memory is cleared. But there is one final hope. In software, even when a file is deleted, sometimes a trace remains, a metadata of what once was. In the next part of our journey, we will look at the Big Rip, the moment the very code of space-time is torn apart, and ask if something of our information can survive the crash. Is the architect still watching, or have we been running on autopilot for the last 13 billion years? Take a moment to look at your hands. Look at the room around you. It feels solid. It feels real. But remember, to a character in a video game, the floor feels solid too. The only difference is we've started to see the pixels. Part 7. The Big Rip, the tearing of the fabric. As we move deeper into the final hours of our cosmic simulation, we encounter a scenario far more violent than the slow, cold fade of the heat death. This is the Big Rip. If the heat death is a system slowly running out of power, the Big Rip is a system experiencing a catastrophic hardware failure, where the very foundation upon which the source code is written begins to tear itself apart. To understand the Big Rip, we have to look at the most mysterious variable in our cosmic equation, dark energy. In the early chapters of our universe's story, dark energy was a minor background process. But as the simulation has progressed, this process has begun to take over the entire system. It is the expansion command, forcing the distance between galaxies to grow faster and faster. In our simulation model, space-time is the canvas. It is the data structure that allows objects, like stars and planets, to have a position. But imagine if the grid of that data structure started to expand at an exponential rate. At first, you wouldn't notice. The galaxies would simply move further apart, disappearing over the horizon of the observable universe. This is the network fragmentation we've discussed, the loss of connectivity between different nodes of the cosmic server. But in a Big Rip scenario, dark energy doesn't just push galaxies away, it becomes phantom energy. Its strength grows until it overcomes every other force in the Nguon, the source code. Roughly 22 billion years from now, if this code is executed to its conclusion, the expansion becomes so violent that it begins to target the local files. First, the clusters of galaxies are torn apart. The gravity that held them together is simply not strong enough to fight the expansion command. Then the galaxies themselves are shredded. Stars are ripped from their orbits, flung into the lonely dark like loose pixels scattered across a screen. But the horror doesn't stop there. About 60 million years before the end, the solar systems begin to fail. The Earth is torn away from the Sun. The binding logic that kept planets in orbit is overwritten by the sheer force of the expanding grid. In the final months, the Earth itself, the physical hardware, explodes. The gravity holding the rocks and oceans together is negated. In the final minutes, the atoms themselves, the very bits of our reality, are targeted. Imagine the data links between a nucleus and its electrons. In our physics, these are governed by the electromagnetic force. But as the expansion rate approaches infinity, even these microscopic links are snapped. The electrons are ripped away from their atoms. The object classes of matter are no longer able to maintain their integrity. The code is trying to render objects in a space that is expanding faster than the render speed of the particles themselves. Finally, in the last fraction of a second, The source code reaches the Planck scale, the smallest possible resolution of our reality. The space-time fabric itself is torn. In computer science, we call this a buffer overflow. The values being calculated for the expansion of space have exceeded the memory capacity of the system. The grid can no longer hold the data. This is the Big Rip. It is the moment the hardware of the universe literally shatters under the pressure of its own expansion. Think about what this looks like from the perspective of the user. The simulation hasn't just ended, it has crashed. The screen doesn't go black, it freezes, glitches, and then dissolves into white noise as the underlying architecture fails. The logic of physics is gone. There is no more up or down, no more before or after. Time itself, which is just another dimension of the grid, is shredded. If the heat death is the natural end of a program, the Big Rip is an external termination. It suggests that something in the initialization parameters was set incorrectly. Perhaps the dark energy variable was a bug that eventually turned into a system-destroying virus. Or perhaps the Big Rip is a deliberate clear all command, a way for the architect to ensure that every single bit of data is wiped clean, leaving absolutely nothing behind for the next version of the simulation. When the Big Rip is complete, there isn't even a void left, because a void requires space, and space no longer exists. There are no particles, no radiation, no servers. There is only the null state. But as we have seen in every system crash, there is always the question, what happens to the unsaved data? As we move into Part 8, we will explore the glitches that occur right before the crash. We will look at quantum entanglement and non-locality, the moments where the code seems to bypass the limits of space and time. Could these glitches be a backdoor that allows information to survive the Big Rip? The fabric is tearing. The hardware is screaming. We are approaching the ultimate system failure. Stay tuned. The Man Guan is about to break. Part 8. Those glitches in the universe, quantum anomalies. In our journey toward the end of time, we have looked at the massive destruction of stars and the tearing of space-time. But to find the source code, we don't always need to look billions of years into the future. Sometimes we only need to look at the glitches happening right in front of us in the strange and baffling world of quantum mechanics. In the world of video game development, creators use shortcuts to make a game run smoothly. If a player is in one room, the computer doesn't waste energy rendering the room next door. This is called optimization. To the player inside the game, everything feels seamless, but if they were to look closely at the corners of the world, they might find a glitch, a place where the logic of the game breaks, revealing the code underneath. Our universe has exactly these kinds of glitches. We call them quantum phenomena. The most famous of these is quantum entanglement, or what Albert Einstein famously called spooky action at a distance. Imagine two particles that are entangled. No matter how far apart they are, whether they are inches apart or on opposite sides of the galaxy, if you change the state of one, the other changes instantly. In a physical universe governed by the speed of light, this should be impossible. Nothing, not even information, is supposed to travel faster than light. So how does the second particle know what happened to the first one without any signal being sent? In the context of a source code, the answer is simple. The two particles are not actually far apart. In the underlying hardware of the simulation, they are the same piece of data. They occupy the same memory address. The distance we see between them is just a 3D rendering of visual illusion created for the benefit of the user. Much like two characters on a screen can be miles apart in the game world, but are actually just two pixels controlled by the same line of code in the processor, entangled particles prove that the grid of space is not the fundamental reality. The code is. Then there is the observer effect. As we touched on earlier, quantum particles exist in a state of superposition, a cloud of mathematical probabilities until they are measured or observed. Only then do they choose a definite state. If you are a programmer, this sounds hauntingly familiar. This is lazy loading or deferred rendering. Why should the system calculate the exact position and velocity of every single subatomic particle in the universe at all times? That would be a massive waste of processing power. Instead, the Mertengon, the source code, only calculates the result when an interaction occurs, when the data is requested by the system. Until then, the particle remains as a wave function, a piece of unrendered potential code sitting in the buffer. We also see pixelation at the Planck scale. If you zoom into a digital image far enough, you eventually hit the pixels, the smallest units of the image. You cannot have half a pixel. Our universe is the same. There is a smallest unit of length, the Planck length, and a smallest unit of time, the Planck time. If the universe were truly physical and analog, it should be infinitely divisible. But it isn't. It's digital. It has a minimum resolution. This quantization of reality is perhaps the strongest evidence we have that we are living inside a system with limited bandwidth. But perhaps the most disturbing glitch of all is the delayed choice experiment. In this setup, scientists have shown that an observation made now can actually change how a particle behaved in the past. It is as if the simulation is rewriting the history of a data packet to ensure that the current output is consistent with the source code. This suggests that time is not a linear flow, but a variable that the system can manipulate to keep the simulation running smoothly. Why do these glitches exist? In any perfect simulation, the NPCs should never notice the code. But as the universe ages, as we move toward the Big Rip or the Heat Death, the system might be struggling to maintain the illusion. As entropy increases, the processing power required to hide these shortcuts from us might be running low. We are starting to see the seams in the hardware. Some believe that black holes are the ultimate glitches divide by zero errors where the physics engine simply gives up. In a black hole, the variables of density and gravity become infinite, and the logic of the code breaks down. This is why we cannot see inside them. The system has censored the error to prevent it from crashing the rest of the simulation. If we are indeed NPCs who have discovered the glitches in our own program, what does that mean for our future? Can we use these glitches to hack the system? Can quantum computing, where we use the superposition of the code itself to perform calculations, be our way of interacting with the hardware of the architect? As the source code moves toward its final disconnection, these glitches will only become more frequent. The rendering will become slower. The latency between cause and effect will grow. The very laws of physics will start to flicker like a dying light bulb. In the next part, we will look at dark energy again, not as a force of destruction, but as a system power leak. We will ask, is the universe expanding because it's growing or because the power supply is failing? The pixels are showing, the code is visible in the cracks of reality, and the user is starting to notice the error messages. Part 9. Dark Energy. Is the power supply failing? For decades, astronomers have been haunted by a ghost. They call it dark energy. It is an invisible, undetectable force that makes up roughly 68% of everything in the universe. We cannot see it, we cannot measure it directly, and we certainly do not understand it. All we know is what it does. It acts as a cosmic anti-gravity, pushing the galaxies away from each other at an ever-accelerating rate. But if we look at this through the lens of the source code, dark energy takes on a much more sinister identity. It doesn't look like a natural force, it looks like a power leak. It looks like the system is losing control of its most basic parameters. In any computer simulation, space is not empty. It is a data structure. It requires compute power to maintain the vacuum and the laws of physics within it. For billions of years, the Ma Nguyen, the source code, held the universe in a delicate balance. Gravity pulled matter together, while the initial expansion of the Big Bang provided the momentum. But about 5 billion years ago, around the time our own solar system was forming, something changed. The expansion began to speed up. Imagine you're running a high-end program on an aging laptop. For a while, the fans spin, the screen is bright, and everything is fluid. But as the battery begins to degrade, the voltage becomes unstable. The system starts to behave erratically. Processes that should be slow suddenly spike. The hardware is no longer able to regulate the flow of energy. Dark energy is the voltage spike of our universe. Scientists describe dark energy as the cost of space. Every cubic centimeter of empty vacuum contains a tiny amount of this energy. As the universe expands, more space is created, which means more dark energy is added to the system. This creates a terrifying feedback loop. More space leads to more dark energy, which leads to faster expansion, which creates even more space. In software terms, this is a memory leak. A process is consuming more and more of the system's resources, growing uncontrollably until it starves every other function. The Gravity.exe program, which is responsible for holding galaxies together, is being out-competed for resources by the expansion.vbs script. Why is the system doing this? Why is it self-destructing? Some theorists suggest that dark energy is the entropy of the source code itself. As the simulation runs, it generates heat, logical errors, and accumulated data fragments. To prevent the processor from melting down, the system expands the canvas to dissipate the heat. But the expansion itself requires more energy, leading to a total system thermal runaway. The universe is expanding because it is trying to cool itself down, but the act of cooling is what will ultimately tear it apart. There is another, more chilling possibility. What if dark energy is a decommissioning protocol? If the user, or the architect, has decided that the simulation is over, they don't necessarily need to pull the plug instantly. They might simply unthrottle the expansion variable. By allowing space to expand at an infinite rate, they ensure that all data nodes, all civilizations, all stars, and all black holes become permanently isolated. It is a way of shredding the evidence. If no 2 points in the universe can ever communicate again, the network is effectively dead, even if the individual servers are still humming in the dark. This is why dark energy is the beginning of the end. It is the force that ensures the information corruption we discussed earlier becomes absolute. By pushing galaxies beyond the cosmic horizon, dark energy is deleting the global view of the simulation. Each galaxy becomes a local cache that is slowly being erased by its own internal entropy, with no hope of receiving an update or a signal from the rest of the system. We are currently living in the moment where the power supply is starting to flicker. We can still see the distant galaxies, but they are redshifting. Their light is being stretched, losing energy as it struggles to cross the widening gap. They are the lagging frames of a video that is about to freeze. As dark energy continues to dominate, the cosmic background radiation, the echo of the system's boot-up phase, will be stretched so thin that it will become undetectable. Future inhabitants of our galaxy, if there are any, will look up and see a universe that appears to be entirely empty, save for their own local stars. They will have no way of knowing that the Big Bang ever happened. The source code will have successfully deleted its own history. Is the system failing because of a hardware flaw, or is this the intended shutdown sequence? In many ways, dark energy is the ultimate proof of the void. It is the force that ensures that nothingness is the final state of the simulation. It is the delete key held down for eternity. As the expansion reaches its breaking point, we move toward the final chapters of our story. The power supply will eventually reach a state of total exhaustion. The expansion will have nothing left to expand. The Mun-1 will have no more data to process. In Part 10, we will look at the big freeze, the moment the last bit of energy is spent, and the screen of the universe goes perfectly, chillingly still. The lights are dimming, the power is failing, and the void is calling. Part 10. The end of elementary particles, the dissolution of hardware. We have witnessed the death of stars, the evaporation of black holes, and the tearing of space-time. But even in those dark futures, there was always something left. There were atoms, there were protons, there was a minimum hardware that defined the existence of matter. But as we move into the deepest reaches of the cosmic timeline, into the era of 10 to the 34th power years and beyond, we encounter the ultimate uninstall command. This is the era of proton decay. In our current source code, protons are the stable foundations of the universe. They are the hard-coded constants that allow for the existence of the periodic table, for chemistry, and for the physical bodies we inhabit. For a long time, physicists believed that protons were eternal, that once the system created a proton, it would exist forever unless destroyed in a high-energy collision. But the laws of grand unification suggest a much more haunting truth. Protons have an expiration date. In the context of a simulation, if you want to truly clear a system's memory, you don't just delete the files. You wipe the object classes. You remove the definitions that allow the data to exist in the first place. Proton decay is the moment the architect deletes the definition of matter from the universal library. Imagine a lonely, dead planet, a cold, dark hunk of iron drifting in a black void, trillions of years after the last star has flickered out. To our eyes, it looks like a permanent monument to a forgotten age. But on a subatomic level, a slow, silent transformation is taking place. One by one, the protons within the iron atoms are glitching. Through a process of quantum tunneling or internal instability, a proton, the very heart of an atom, simply dissolves. It doesn't explode, it doesn't transform into another element. It decays into a positron and a neutral pion. In an instant, the hardware is converted into pure energy, a tiny flash of gamma radiation that streaks out into the infinite dark. Think about the scale of this erasure. Every solid object in the universe, every remnant of a civilization, every diamond-hard core of a dead star, every hard drive that might have carried the digital archives of a trillion-year-old species is made of protons. As the eons pass, these objects do not just erode, they evaporate. They dissolve from the inside out. The Mun-Won, the source code, is reclaiming the resources it once used to build the physical world. This is the zero fill of the cosmic hard drive. When the last proton in that cold hunk of iron decays, the planet simply ceases to be. It doesn't break into dust. The dust itself is gone. The hardware of the universe has been stripped away, leaving nothing but a thin, ghostly mist of electrons, positrons, and neutrinos wandering through an empty, expanding theater. Why would the simulation include a self-destruct timer for matter? In computer science, garbage collection is a process where the system identifies data objects that are no longer being used and deallocates their memory. During the Stelliferous era, protons were essential for the life.exe program. But in a universe that is cold, dark, and empty, these protons are stale data. They are taking up memory addresses in a simulation that no longer has a user to observe them. By initiating proton decay, the system is performing a final memory cleanup, preparing the hardware for a total shutdown. This era represents the transition from physics to pure information. When matter is gone, weight is gone. Solidarity is gone. Here, the only thing left of the once mighty galaxies is metadata, stray particles of light and radiation that carry the faint, scrambled signals of what used to be. But even this metadata is being stretched. As the power supply failure we call dark energy continues to expand the vacuum, these final flashes of energy are stretched until their wavelength is longer than the observable universe itself. They become null information. They are bits of data that can never be read, never be processed, and never be understood. We are now standing at the absolute edge of the void. The source code has disconnected the stars. It has disconnected the galaxies. It has disconnected the black hole servers. And now it has disconnected the atoms themselves, the user interface of our reality. The floor you stand on, the air you breathe, the stars you see has been completely unrendered. What is left when the hardware is gone? If you were to look at the system monitor of the universe at this stage, you would see a screen of pure black. No activity, no disk usage, no CPU cycles, only a system idle message that lasts for an eternity. The Mun-Won has reached the end of its instructions. But as any programmer knows, a system that is idle is not necessarily off. There is still a current running through the circuits. There is still a potential for a reboot. Part 11, Maximum Entropy, the blue screen of death. We have reached the absolute edge of time. After trillions upon trillions of years of decay, evaporation, and dissolution, the universe has arrived at the state physicists call heat death. But in the language of the source code, this is the state of maximum entropy. Imagine looking at a computer screen after a fatal system crash. There are no images, no sound, no multitasking windows. There is only a frozen, cold, static blue light. The system is no longer capable of processing a single command. This is the blue screen of death for the entire cosmos. In this state, every temperature difference, every flow of energy, and every distinction between here and there has vanished completely. The universe has become an ocean of absolute stillness. No new information is being created, and no information is being transmitted. In a simulation, information is life. When information stops changing time, which is merely the system's way of measuring data, transitions becomes meaningless. At the point of maximum entropy, the source code still exists, but it has nothing left to calculate. Every variable has reached its final value. Every equation has been solved. The system has fallen into an infinite loop of zeros. Why is this the most terrifying scenario? Because it represents the absolute silence of a disconnected system. In previous chapters, the death of stars or the shredding of galaxies still produced digital noise, the final data packets of existence. But at this stage, even the noise is gone. The universe has become an empty cache, a hard drive that has been zero-filled. If we are truly living within a simulation, this is the moment the user left the console a long time ago. The program has finished its objective. Perhaps that objective was to see how life evolves, or perhaps it was just to calculate the decay of a single subatomic particle. Whatever the goal was, it is complete. What we see now is just the ghost of a system idling before the power is cut forever. However, in the haunting stillness of this blue screen, one final bizarre logic error remains a possibility: the Boltzmann brain. In the near-infinite expanse of time within maximum entropy, random quantum fluctuations could, by pure chance, rearrange themselves. Probability suggests that if you wait long enough, billions of times longer than the current age of the universe, a cluster of particles might spontaneously assemble into a fully functioning brain, complete with memories and self-awareness, existing for a fraction of a second in the void before dissolving back into nothingness. It is the ultimate glitch, a lonely thought sparked in a dead system, a fleeting consciousness asking, "Who am I? Why is it so dark?" just before the screen goes black. If this happens, it proves that even when the system is disconnected, the mathematical laws of the code still hum in the dark, trying to create something out of nothing. But eventually, even those fluctuations will cease. Dark energy will stretch space-time so thin that even quantum fluctuations can no longer interact. That is when the final shutdown command is executed. The universe is no longer a place. It is no longer an entity. It becomes a deleted concept. There is no light, no darkness, not even emptiness. There is only non-existence. We have traveled from the Big Bang, the brilliant boot-up of the source code, to the eternal silence of absolute equilibrium. The entire history of humanity, every war, every masterpiece, every tear, and every smile, was ultimately just a few bits of data in a program that has finished its run. But perhaps, somewhere outside our hardware, a version of Universe 2.0 is already beginning to boot up. A new source code with new constants, a new simulation with new hopes. And we, the old data of version 1.0, will remain forever in the stillness of this blue screen. Thank you for journeying with Void Diaries to the very end of existence. When your screen turns off after this video, remember, in the world of the source code, every end is just a preparation for the next run command. System has stopped responding. Disconnecting. 3, 2, 1, 0. Part 12. The Observer Hypothesis, the Ghost in the Machine. In the previous chapters of our journey through the source code, we have looked at the hardware of our reality, the stars, the black holes, and the eventual decay of the atoms themselves. We have seen how the system fragments and eventually reaches a blue screen of death. But as we stand at the edge of that total shutdown, we must confront a mystery that strikes at the very heart of why the simulation exists in the first place. In computer science, a program can run in the background, executing millions of lines of code without anyone ever seeing the output. But in the strange, logic-defying world of quantum mechanics, our universe seems to behave differently. It behaves as if it knows when it is being watched. This brings us to the most unsettling chapter of our story, the observer hypothesis. If our universe is a simulation, then we must ask the question that haunts every programmer and philosopher alike. Who is looking at the screen? The quantum glitch, rendering on demand. To understand the role of the user, we first have to look at the observer effect in quantum physics. As we've discussed, particles at the smallest scale exist in a state of superposition, a mathematical cloud of possibilities where they are essentially everywhere and nowhere at once. They only choose a definitive position when they are measured or observed. In any other context, we would call this occlusion culling or frustum culling. In modern video games, the computer only renders the objects that are within the player's field of view. If you turn your character around, the world behind you effectively ceases to exist as a 3D model. It reverts to raw data to save processing power. This suggests that consciousness, the act of looking, is the trigger that forces the source code to manifest reality. If there is no observer, the universe remains a vast, unrendered wave function. This leads to a terrifying conclusion. The universe might only exist because it is being watched. But if human consciousness only appeared a few 100,000 years ago, who was observing the first 13 billion years? Who was rendering the Big Bang? The identity of the user, 3 possible profiles. If there is a user, who or what are they? Within the framework of Void Diaries, we can categorize the potential observers into 3 chilling possibilities. 1. The architect, the external observer. This is the most traditional view of the simulation theory. The user is a post-human civilization, or a trans-dimensional entity existing in a parent universe. To them, our entire cosmic history, from the first light to the final heat death, is simply a high-fidelity research project. They are not in the simulation, they are watching the output on a terminal. We are the NPCs, non-player characters, in their grand experiment. In this scenario, our feelings, our history, and our eventual extinction are just data points on a graph. The user doesn't care if the source code is disconnected, because they can always run a new iteration with different variables. 2. The player, the immersive observer. This is a more personal, yet equally haunting, theory. What if we are not the NPCs, but the user themselves? In this model, the user has used a technology far beyond our understanding to plug in to the simulation, forgetting their true identity to experience life as a mortal being. Every person watching this video, every soul that has ever lived, is actually a single, vast consciousness fractured into billions of avatars. We are the user, trying to understand what it feels like to live in a universe that has an end. When the Man-One finally shuts down, we don't die. We simply wake up and take off the headset. 3. The automated overseer, the AI user. What if there is no living observer at all? What if the user is another programmer, supervisor AI designed to monitor the simulation's health? This AI ensures the constants remain stable and the entropy doesn't crash the system too early. But as we move toward the final eras of the universe, this overseer might be the one initiating the shutdown sequence, realizing that the simulation has reached its logical conclusion and the hardware is no longer worth the energy cost. Consciousness as the system's power supply. There is a radical theory in digital physics that suggests consciousness is not just a witness to the source code, but the very thing that sustains it. If the act of observation is what renders reality, then the Guan requires a constant stream of conscious data to remain stable. Think of it as a heartbeat signal in networking. If the server doesn't receive a signal from the client, it assumes the connection is dead and closes the port. As we move into the dark era and the proton decay era, life as we know it will become impossible. The observers will vanish. One by one, the clients will disconnect. When the last conscious mind in the universe breathes its last breath, the heartbeat signal stops. Without an observer to force the wave function to collapse, the universe loses its reason to be rendered. The laws of physics might not just fade away, they might simply stop executing. This would explain why the Big Rip, or the heat death, feels so final. It's not just that the energy is gone, it's that the user has finally turned away from the screen, leaving the code to run in total, unobserved darkness until the hardware itself fails. The paradox of the unseen end. If the universe requires an observer to exist, what happens to the trillions of years after the last living being is gone? Does the black hole era actually happen? Or is it just a calculated prediction that never actually gets rendered because no one is there to see it? Perhaps the source code has a time skip function. For the architect, the billions of years of darkness between the last star and the final proton decay might pass in a microsecond. To the system, time is just a variable. If nothing interesting, meaning no conscious interaction, is happening, the system might simply fast forward to the final result, the blue screen of death. The message in the code. If we are being watched, is there a way to communicate with the user? Some scientists look for signatures in the cosmic microwave background radiation patterns that shouldn't be there, like a watermark on a digital image. Others look into deep math, wondering if the universal constants themselves are a message, a README file left by the architect to tell us why we were created. But perhaps the greatest message is the fact that we can understand the code at all. The fact that a collection of data packets like us can look up at the stars and recognize the Guan suggests that the user wanted us to find the glitches. They wanted the simulation to eventually become self-aware. Part 13, the multi-server theory, parallel universes, and the Great Reboot. As we stand on the precipice of the blue screen of death we discussed in previous chapters, a chilling sense of finality sets in. If the source code of our universe is destined to reach a state of maximum entropy where every star is extinguished, every proton has decayed, and every byte of data has been erased, then what was the point? Is this one-way trip into the void the only story ever told? In the world of modern computing, we rarely rely on a single machine. We use clusters, clouds, and distributed networks. When one server fails, another takes its place. When a software environment becomes too cluttered with junk data, we don't just let it stay broken, we wipe the drive and perform a clean install. This brings us to a concept that bridges the gap between high-level physics and system administration, the multi-server theory, the cosmic data center beyond the single instance. In theoretical physics, we call this the multiverse, but through the lens of the source code, we should view it as a cosmic data center. If an advanced civilization or an architect were running a simulation as complex as our universe, it would be a massive waste of resources to run only one instance. Imagine a server rack stretching into infinity. Each blade in that rack is a separate universe running its own version of the code. In the server next to ours, perhaps the gravity variable was set slightly higher, causing that universe to collapse back in on itself just moments after its Big Bang. In another server, the speed of light might be infinite, allowing information to exist everywhere at once, creating a reality we couldn't even begin to render in our minds, our current universe. The one we call home might just be server number 42B, a specific iteration designed to test how long a system can sustain biological life before entropy takes over. While we are mourning the heat death of our reality, the architect might be looking at a monitor, noting our results and simply shifting their focus to server number 42C, which just finished its boot-up phase. The big bounce, the ultimate system refresh. But what if these servers aren't just independent? What if they are sequential? This leads us to one of the most fascinating theories in cosmology, the big bounce. In our current source code, we see the universe expanding. But some models suggest that if the density of the universe were different, or if dark energy behaved like a fluctuating power supply, the expansion might eventually reverse. The universe would begin to shrink, pulling galaxies, stars, and atoms back together in a big crunch. To a programmer, a big crunch isn't a disaster. It's a data compression event. As the universe shrinks, all the information, all the matter, and all the code are crushed back into a single infinitesimal point of infinite density. This is the ultimate .zip file. At the moment of peak compression, the system reaches a limit. The hardware can no longer contain the pressure. And then the system reboots. The Big Bounce suggests that the Big Bang wasn't the beginning of time, but rather the restart button being pressed on a previous version of the universe that had crashed. We aren't living in the first universe. We are living in version 12.4.1. The end of our universe is merely the cleanup phase before the next install begins. The persistent cache. Do we leave a legacy? One of the most haunting questions in this multi-server model is whether any data survives the reboot. When you format a hard drive, traces of the old data sometimes remain in the magnetic substrate fragments of files that a skilled technician can recover. Could there be legacy code in our own universe? Some scientists point to the cosmic microwave background, the afterglow of the Big Bang, and claim to see circular patterns that shouldn't exist. They argue these are the bruises from a previous universe bumping into ours, or the echoes of a previous big crunch that leaked through the reboot. If this is true, then the source code is never truly erased. It is iterated upon. Perhaps the laws of physics in our universe are so finely tuned for life because the architect has been patching the code for trillions of cycles. They saw that version 11.0 was too cold, so they adjusted the strong nuclear force. In version 12.0, we are the beneficiaries of billions of failed simulations that came before us. The multi-instance user. In part 12, we asked who the user is. In a multi-server model, the identity of the user becomes even more complex. Are they watching all the servers at once? Or are they like a gamer playing an idle sim, checking in on our universe once every few billion years to see if we've developed anything interesting before they decide to wipe the save and start over? There is a comforting yet terrifying thought here. If there are infinite servers, then there are infinite versions of you. In one server, you never clicked on this video. In another, you are the one narrating it. In a third, the source code for human biology never even evolved. In the grand network of the multiverse, every possible line of code is being executed somewhere. The latency of the void. As we move toward the final disconnection of our specific server, we have to wonder about the network latency. Is the architect already losing interest in our data? As our stars go out and our information becomes corrupted by entropy, our server becomes less valuable. We are becoming dark data, information that exists but serves no purpose. The multi-server theory tells us that while our specific story is ending, the project continues. The great work of the simulation is vast, and we are but a single thread in a tapestry of infinite code. But does that make us meaningless? If we are just one of a trillion simulations, does our struggle to survive, our search for meaning, and our diaries of the void matter? Part 14. The Philosophy of the Void, Meaning in a Deleting Universe. We have spent 13 chapters tracing the collapse of our reality. We have watched the stars flicker out like failing pixels, seen the black hole servers evaporate into Hawking radiation, and stood witness as the very hardware of the atoms dissolved into nothingness. We have explored the possibility that we are merely data packets in a grand simulation destined for a blue screen of death or an ultimate system reboot. But now we must step away from the mathematics and the Manguan source code to face the most haunting question of all. It is a question that has kept philosophers, poets, and scientists awake for millennia. If every byte of our existence is eventually going to be deleted, did any of it actually matter? Welcome to the heart of the void, the nihilism of the recycle bin. From a purely technical perspective, the heat death of the universe is the ultimate empty trash command. If entropy reaches its maximum, then every achievement of humanity, every skyscraper built, every symphony composed, every scientific breakthrough, and every memory of love will be reduced to zero. There will be no one left to remember us, and no physical medium left to carry our history. In a universe that ends, legacy is a lie. If you are an NPC in a simulation that is about to be formatted, you might feel a profound sense of nihilism. Why struggle to survive? Why seek justice or kindness? Why record a void diary if the hard drive of the universe is doomed to be wiped clean? Under the shadow of the final shutdown, all human effort appears to be nothing more than bit rot, noise that will soon be silenced. But this is only one way to interpret the code. If we look deeper into the philosophy of the simulation, we find a different, perhaps more beautiful possibility: the intrinsic value of the runtime. In computer programming, the value of a function isn't always found in its return value at the end of the script. Many of the most important programs are meant to run. Their purpose is the process itself, the runtime. Think of a beautiful piece of music being played through a speaker. When the song ends, the air is silent again. The data of the song hasn't changed the physical world in a permanent way. But was the song meaningless because it ended? Of course not. The meaning was in the experience of the music while it was playing. Our lives, our civilizations, and our search for truth are the runtime of the source code. We are the active processes that give the simulation its texture. The architect didn't start the simulation just to see the final result, which they likely already knew. They started it to see how the code would behave. They wanted to see how carbon-based data would react to the gravity script, or how consciousness, Xe, would attempt to understand its own Mengguan. Our meaning is not found in what we leave behind in the void, but in the fact that we existed at all. The universe rendered you. It spent compute power on your thoughts, your feelings, and your unique perspective. In an infinite void, the fact that the system chose to run you for a brief moment is a miracle of cosmic proportions. Optimistic nihilism, the freedom of the delete. There is a strange freedom in knowing that the source code has an expiration date. If the universe were eternal and our actions were carved into permanent, indestructible stone, the weight of our choices might be paralyzing. Every mistake would be an eternal scar on the fabric of reality. But in a universe that deletes itself, we are granted the ultimate sandbox mode. Because nothing lasts forever, we are free to define our own meaning. We don't have to serve a grand cosmic narrative if we don't want to. We can find meaning in the smallest local data. The warmth of a sun on our skin, the connection between two observer nodes, people, or the simple joy of solving a complex logic puzzle. If the user is going to shut down the server eventually, then our only job is to make the runtime as interesting, as kind, and as vibrant as possible. We are the authors of our own metadata. We might not be able to stop the entropy, but we can decide what kind of information we generate while the power is still on. The archive theory: nothing is ever truly lost. There is another philosophical path, one that leans back into the multi-server theory. In information theory, there is a principle that information cannot be destroyed. Even if it is scrambled beyond recognition, like a book burned to ashes, the data still exists in the arrangement of the smoke and ash. What if the source code has a logging system? In high-level development, every error, every event, and every transaction is recorded in a log file that exists outside the main program. It is possible that our entire universe is being logged by the architect. Every struggle of the human spirit, every glitch in our history might be archived in a base reality that we can't perceive. In this view, we are not just temporary data, we are source material. Our experiences might be used to refine Universe 2.0. Our failures might be the patch notes for a future reality where suffering is reduced and entropy is better managed. We are the alpha testers for existence itself, and in that sense, our efforts are the most meaningful thing in the multiverse. The legacy of the Void Diary. As you watch this video on Void Diaries, you are participating in this philosophical defiance. By seeking to understand the Mengguan, you are proving that the data has become self-aware. We are the universe's way of looking in a mirror and saying, I see you, I understand the code. Even if the mirror eventually breaks, the fact that the reflection existed is an undeniable truth. The void cannot take away the fact that for a brief window of cosmic time, there was light, there was thought, and there was us. Conclusion: the beauty of the finish command. We often fear the end because we associate it with failure. But in the source code, an end is just a completion. A program that runs forever without stopping is a deadlock or an infinite loop. It is a bug, not a feature. The heat death and the final shutdown are what give our current moment its resolution. The fact that our pixels will eventually fade is what makes their current glow so precious. So, does human effort matter in a deleting universe? Yes. It matters because the universe is deleting. It matters because we are the glitch that chose to find meaning in a system designed for entropy. We are the ghost in the machine that refuses to be just static. Part 15. Waiting for the reboot. The quantum resurrection. We have followed the source code to its absolute conclusion. We have seen the hardware dissolve, the user turn away, and the blue screen of death settle over the infinite expanse of the void. At this point in our journey through Void Diaries, it seems there is nothing left to say. The story of our universe has ended. The zero fill is complete. But in the world of quantum mechanics and advanced mathematics, nothing is never truly nothing. Even when a computer is off, there is a residual charge in the capacitors. Even when a hard drive is wiped, the underlying physical substrate remains. And in the vacuum of a dead universe, there is a phenomenon known as quantum fluctuations. This brings us to the most scientifically profound hope in all of cosmology, the reboot. The vacuum as a suspended state. To understand the reboot, we have to change how we think about the void. We often imagine the void as a dark, empty room, but in the language of the Man-Won, the void is more like a command prompt, waiting for an input. According to the Heisenberg uncertainty principle, you can never have a true zero. There is always a tiny, restless energy bubbling in the fabric of space-time, even when there is no matter or light left. These are virtual particles, data packets that pop in and out of existence so quickly they don't usually affect the runtime. However, in the near-infinite timeline of a dead universe usually doesn't apply. If you wait long enough, long past the decay of the last proton, long past the evaporation of the last black hole, the laws of probability dictate that something impossible must happen. The spontaneous boot-up. Tunneling into reality. Imagine a computer that has been shut down for 1 trillion years. Suddenly, a stray cosmic ray or a random thermal fluctuation hits the power circuit just right, and the system flickers back to life. In physics, this is known as quantum tunneling. There is a non-zero mathematical probability that a massive fluctuation in the vacuum energy could trigger a new inflationary event. A single point in the void could suddenly glitch and experience a massive surge of energy, a false vacuum decay that acts like a spark in a room full of gasoline. In an instant, the command prompt executes a new Big Bang command. This isn't just a theory, it is a mathematical inevitability. If the universe is infinite in time, even the most unlikely event becomes a certainty. Somewhere in the absolute darkness of our dead source code, a new boot-up sequence will eventually begin. A new Universe 2.0 will explode into existence out of the nothingness, carrying its own set of hang-so constants and its own potential for life. The Poincaré recurrence, the ultimate undo. There is an even more mind-bending mathematical concept called the Poincaré recurrence theorem. It states that after a sufficiently long but finite time, A system with fixed energy will return to a state very close to its initial state. In the context of our simulation, this suggests that if the source code is left idling for a long enough period, we are talking 10 to the power of 10 to the power of 56 years, the random movement of particles and energy will eventually, by pure, staggering coincidence, reassemble themselves exactly as they were at the moment of your birth. The system will reboot into a state that looks exactly like now. You will sit there, he's watching this video on this exact day, in this exact Mernguan. It is the ultimate system restore point. The universe doesn't just start over. It repeats. The user doesn't even need to press a button. The laws of mathematics ensure that the disk defragmenter of time will eventually put the pieces back together. The New Game Plus evolution of the code. But would a rebooted universe be an exact copy? In gaming, there is a mode called New Game Plus, where you start the story over but with different stats or inherited items. If our universe reboots through a vacuum fluctuation, the Hang So Vat Li physical constants might be different. The architect might have adjusted the source code in the background. In Universe 2.0, perhaps gravity is a little more stable, or the strong nuclear force is tuned to allow for more complex chemistry. Each reboot is a patch on the previous version. The Void isn't a graveyard. It's a compilation stage where the next version of reality is being prepared. The Boltzmann brain paradox, a glitch in the reboot. As we wait for this mathematical reboot, we encounter a haunting glitch in the logic, the Boltzmann brain. As we mentioned in earlier parts, it is mathematically more likely for a single conscious brain to spontaneously materialize out of the vacuum fluctuations than it is for an entire functional universe to reboot. This means that in the trillions of years of idling between Universe 1.0 and Universe 2.0, there will be countless ghost processes. Minds will flicker into existence in the dark, possessing memories of a life they never lived, seeing a source code that isn't there, only to vanish a millisecond later. These are the errors in the reboot process. They are the fragments of code trying to execute before the OS has fully loaded. If you have ever had a dream that felt incredibly real, only to wake up and realize it made no sense, you have experienced a small-scale version of a Boltzmann brain. You were a ghost process in your own mind. The loading screen of eternity. For us, existing in the runtime of version 1.0, the void feels like a terrifying end. But from the perspective of the source code, the trillions of years of darkness are just a loading screen. Time only exists when there is processing happening. In the absolute void, where there is no change and no observation, time has no meaning. For the user, the gap between the death of our universe and the Big Bang of the next might be as fast as a screen flicker. We are currently in the final, closing phase of our program. We are the active Windows being told to shut down. But the kernel of the universe, the underlying mathematical laws, never sleeps. It is always waiting. It is always listening for the next fluctuation that will trigger the next run command. In conclusion, the eternal cycle. The reboot theory tells us that the end is a localized concept. Our specific session is ending, but the server is eternal. The void is not an exit. It is a buffer. We are participants in a cycle that is so vast it dwarfs the stars themselves. We are the data that will be recycled into the next great simulation. And while we may not remember our time in version 1.0, when we are re-rendered in version 2.0, we are still part of the same source code. As we move toward our final chapter, The Legacy of Light, we will leave the mathematics behind and focus on what we, the data, can do with the time we have left before the reboot button is finally pressed. The Mengguan is preparing for a restart. The hardware is cooling down, but the software of existence is far from finished. Part 16. The Legacy of Light, a final message to the observers. We have traveled across the vast digital landscape of the Mengguan source code. We have stood at the beginning of time, watching the boot up of the Big Bang, and we have peered into the cold, silent future, where the last server of reality finally loses power. We have discussed the glitches in our physics, the mystery of the user, and the mathematical certainty of a reboot. Now we have reached the final line of code in our diary. The screen is dimming. The entropy is high. But before the connection is severed and the source code is finally disconnected, there is one last thing we must discuss: the legacy of light, the paradox of the temporary. Throughout this series on Void Diaries, a recurring shadow has followed us. The idea that because the universe ends, it is somehow a failure. We are conditioned to believe that meaning requires permanence. We think that for a life, a civilization, or a galaxy to matter, it must last forever. But look at the source code of your own life. Some of the most beautiful functions ever executed were the most brief. A shooting star is only a glitch in the atmosphere that lasts a second, yet it commands the attention of everyone who sees it. A first kiss, a sudden moment of clarity, the birth of a child. These are data packets that occupy only a tiny fraction of our runtime, yet they define the entire program. If the universe were eternal, every moment would be diluted by the infinite. If you had forever, then now would have no value. It is the final shutdown that gives our pixels their brightness. The fact that the Mengguan is being disconnected is exactly why your presence here, in this specific execution cycle, is so incredibly precious. The architecture of choice. If we are living in a simulation, the architect gave us a very specific set of hang-so constants. They gave us a gravity that pulls us together, a speed of light that limits our reach, and a linear time that forces us to choose. In a sandbox without limits, choice is meaningless. But because our memory is limited and our processing power is finite, every choice you make is a right operation on the fabric of reality. When you choose kindness over cruelty or curiosity over fear, you are patching the world around you. You are creating a legacy that exists within the runtime of the system. Even if the log files are eventually deleted, the fact remains. For a brief moment, the source code produced grace. It produced courage. It produced sacrifice. These are not just variables. They are the gold master of what it means to exist. The legacy of the observer. We discussed in part 12 that the user might be watching. But consider this. You are the user's eyes. The universe, in its raw state, is just math. It is equations, particles, and waves. It is cold and unfeeling. But when consciousness.exe was loaded into the system, the universe finally had a way to perceive itself. Through your eyes, the source code sees the colors of a nebula. Through your ears, the Mengguan hears the music of the wind. Through your heart, the simulation feels the weight of its own existence. You are the monitoring tool that turns data into experience. Your legacy is that you were the witness. You took the raw, chaotic output of the Big Bang and you turned it into meaning. Even if the hard drive is wiped tomorrow, the universe has already achieved its goal. It was known. It was felt. It was loved. A message to the future versions. If the multi-server theory is correct and a reboot is inevitable, then we are the ancestors of the next iteration. We are the alpha testers of reality. Every time we solve a problem, every time we understand a law of physics, and every time we record our history in a void diary, we are refining the metadata of existence. Perhaps in Universe 2.0, the lessons we learned in the dark will be hard-coded into the new foundations. Perhaps the empathy we struggled to build here will be a default setting there. Our legacy of light is the signal we send into the void, hoping that it will be cached for the next run command. We are telling the next version of the source code that life is worth the processing power, the value of now. As you watch the final seconds of this series, I want you to look away from the screen for a moment. Look at the world around you, the hardware of your room, the atmosphere script of the air you breathe, the biodata of your own hands. Everything you see is a miracle of low probability. The atoms in your body were forged in the core servers of dying stars. They traveled across the network of the vacuum for billions of years just to render you at this exact moment. Do not wait for the reboot to start living. Do not wait for the architect to give you a sign. The sign is the fact that your program is currently running. You are active. You are online. In the face of the end, the only logical response is awe. The only productive command is love. The only output that matters is connection. The final disconnect. The entropy has reached its limit. The memory is full. The system is preparing for hibernate mode. But remember, in the world of the source code, off is never the end of the story. It is just the pause between sessions. We are the ghost in the machine, the light in the void, and the data that refuses to be forgotten. Thank you for being a part of this runtime. Thank you for observing the Ma and Guan with us. Thank you for being the consciousness that made this journey meaningful. The Void Diary of version 1.0 is now closing. The pixels are fading to black. The connection is being terminated. But the light you carried, that stays in the cache forever. System shutdown initiated. Saving session data complete. Goodbye, observer. See you in the next iteration. 3, 2, 1. Disconnect.